Dear students, welcome to my YouTube channel Unique Physics by HJ Sir. Here we will discuss 12th Physics, chapter number 1, Electric Charges and Field. Now, our next topic is explain electric flux. Last time we explained electric field and its property. Now here we are going to explain electric flux. It is denoted by delta phi. Now the electric flux delta phi, okay, remember symbol of electric flux delta phi, link with any surface is given by, so this is our equation of electric flux. Delta phi is equals to vector E dot vector delta S. This is our dot product, scalar product. So delta phi is equals to vector E dot vector delta S. If we remove this dot product, then we can write this equation as E delta S cos theta. Now what is E? So E is known as electric field or electric field vector. What is delta S? Delta S represent surface area vector of that given surface, okay, and here we have symbol theta. So theta represent angle between vector E and vector delta S, angle between these two vector quantity. Now remember one more concept for electric flux. So electric flux is directly proportional to the number of field lines, number of electric field lines passing through the given surface. Means electric flux delta phi is directly proportional to capital N, number of field line passing through the surfaces. Now here we will consider two different situations for electric flux. Theta is known as angle between vector E and vector delta S. Suppose this is a given surface, okay, and here these vectors represent electric field vectors. So electric field prevailing in plus x direction. For this given surface, this is surface area vector. From this figure we can say that vector E and vector delta S both are in same direction, both are parallel, okay. That means angle theta between vector E and vector delta S is 0. Theta 0, here we have cos function, so cos 0 is equals to 1. So delta phi is equals to, we have equation E delta S. This is called maximum flux, okay. So for 0 angle, flux link with this surface is equals to E delta S, that is maximum flux. Now we have another situation. This is our direction of electric field in plus x direction, and for this surface, this vector represent surface area vector, okay. Now from this figure we can say that angle between vector E and vector delta S is 90 degree, okay. This angle is 90 degree, they are normal to each other, okay. So here theta is equals to 90 degree, we have cos function, so cos 90 degree is equals to 0. So delta phi, electric flux link with this surface is 0, and according to this statement, number of field line passing from this surface is also equals to 0. So flux link with the surface is also equals to 0. Now remember units of electric flux. This is our equation of electric flux, electric field into area vector. So using this equation we can find units of electric flux. So first unit of electric flux is Newton per coulomb into area. So unit of area or area vector is meter square. So unit of electric flux is Newton meter square per coulomb. Second unit of electric flux is volt into meter, okay. We will discuss this unit in chapter number 2. Third unit of electric flux is Weber, and generally we use its short form capital W small b. Remember one more point, here we have dot product, and dot product suggests that electric flux is scalar quantity, it has only magnitude. Okay, now here we have three situation. First situation, if field lines are entering to the surface. So this is our suppose closed surface, and here field lines, here we consider four field lines. So these field lines are entering to the surface, that's why electric flux link with this surface is negative, because here we have negative charge, and for negative charge electric field lines are radially inward. Okay, so field lines are entering to the surface, flux is negative. Similarly, if field lines are leaving from the surfaces, this is our surface, this is our positive charge, and for positive charge electric field lines are radially outward, so flux link with this surface is positive. Okay, and last situation, if number of field lines entering to the surface and leaving from the surface are equal. Okay, if number of field lines entering to the surface and leaving from the surface are equal, so delta phi is equals to 0. Now see this figure very carefully. Here we have closed surface, here we consider three field lines that is entering to the surface, and same number three field lines leaving from the surface. So delta phi electric flux link with this surface is 0. So this is your concept of electric flux. We will use this concept in our equation of Gauss law. Thanks.